Alright, I will quickly try and summarize everything there is for this problem, right? Now, in the given problem, and I'll just read it for you, it says that the room is 5 meters long and then it's 4 meters wide and 4.5 meters tall. That's the height of the room is 4.5 meters, it's 4 meters wide and 5 meters of length, right? Now, it says that there's a fan and the fan is suspended from the ceiling at 0.75 meters, right? And what they're asking us to find here is the distance from the corner of the room to the ceiling fan, right? And they're also asking us to find the slope of connectivity from the line, right? That's the true angle is what they're asking us. They're asking us the true length and the true angle from the corner of the room to the ceiling fan. Now, when you kind of visualize the room, and I tried illustrating the room here. I'm not really sure if I've done a great job in doing that, but I think I've done pretty alright. So when I tried illustrating the room right here, what you notice is this right here is the base of the room. This is the floor of the room, correct? This here is the ceiling of the room, and this is the front view, and the observer is somewhere here. Is that right? And there's a ceiling fan in the center over here. So what really happens is when I look at the room from the front view, I see what's the height here? I see 4.5 meters and I see 4 meters. Now we know that in the XY plane, the front view is listed on the top, right? This is my XY line. The front view is in the top and the top view is down. So when I look at the room from the front view, what am I going to see? I'm going to see 4.5 meters tall and 4 meters in width. 4.5 meters tall and 4 meters in width. Now you have to remember that when we deal with application problems, they convert the length, the true length. The length is given in meters, right? And we have to convert that to an appropriate scale. So usually you can take the scale to be anything. For example, here I could have taken the scale to be 1 meter equals 10 mm, but I have taken 1 meter equals 20 mm as the scale, right? And when I convert each of these dimensions into 1 meter is equal to 20 mm, that is to say 4.5 times 20 is 90 mm, 4 meters times 20 is 80 mm, 5 to 100 mm, and 0.75 to 15 mm. So I've converted this. Now when I look at the room from the front view, what do I see? I see the height of the room and I see the width of the room. The height of the room is 4.5 meters or 90 mm, which is 90 mm, and the width of the room is 4 meters or 80 mm, which is 80 mm. So that box there is what the room looks like from the front. Now, what does the room look like from the top? If I look at it from the top, I basically see the length of the room and the width of the room. The length of the room is 5 meters or 100 mm, that is this, and the width of the room is again 4 meters, which is this, right, which is 80 mm. That's 100 mm and 80 mm, and this box here represents the top view of the room. Now, how do you plot the location of the fans in the room? Now, one thing you have to consider is this is my front view, right? When I try to locate the fan in the front view, I basically see that the fan, in the front view, this is the ceiling. This part here is the ceiling. These are the corners. This is the base. This is the floor. This is the ceiling. Now, we know that the fan is hanging from the ceiling. At what distance? 0.75 meters or 15 millimeters. So from the center, the ceiling, I draw 0.75 meters or 15 mm, and that point is where the fan is located in the front view. Now in the top view, the fan is exactly located in the center of the ceiling. So this is the top view and this is the location of the fan, which is in the center of the ceiling, right? Now, when you try to map the location, now what have they asked? They've asked the distance from the corner to the fan, right? So I basically draw a line from the corner, and these are, by the way, apparent lines. So what we'll try doing is we'll try making them thick. These are apparent lines from the corner of the room to the fan. That's one line, and in the top view again from the corner to the fan. So that basically gives me my apparent length. Now what do we have to find? We have to find the true length. How do we convert apparent to true length? What do? You take an arc, right? You take an arc from here. It's this basic true length to apparent length conversion, right? You take one arc there, correct? And then what you do is you draw a straight line down at this locus, correct? So you draw a straight line here, and then what you do is you simply connect them all together, right? I take a line, and since this is a true line, we don't make it thick, we make it thin, and from here, when you connect it there, that gives us the true length. And in the opposite side of the xy, you repeat the same thing. First thing you do is you convert the apparent length to true length by taking an arc, right? I take an arc, and then I draw a straight line. Once I draw a straight line, I basically connect them together, right? And that gives me the true length. Now, this is the true length from the corner of the room to the fan. And what is the true length given? The true length is basically 98.62, correct? It is 98.62, and what does that give us? If you take 98.62 and you divide it by 20, because we have taken the scale to be 1 meter equals 20, right? That gives us 4.931 meters. So this 9.98.62 is basically 4.31 meters. Yeah, and that is the length of the room. Oops. That is the length of the room from the corner to the ceiling, right? It is basically 4.92 something, right? It was 4.92 meters something. So that is the length of the room. Now, angle of connectivity from the base, from the floor. What is the angle of connectivity? It is the theta. It is the true angle from the floor. This is my floor, and this is the angle of connectivity, which is 49.51 degrees, right? And this is how we solve the first problem. Nothing is happening here, just the room, just the front view of the room, the top view of the room. What we did is we tried placing the fans first, and then we connected the corner of the rooms with the fan, and then we tried finding the true length from the corner of the room to the fan. Once we found the true length, the theta, that is the true angle in the front view, is what is the angle of connectivity from the ground. That's the ground to the fan. That is 49.51 is the angle of connectivity, and 4.92 is the true length.